Which of the following molecules are meso compounds? Now, to start this question off, let's review quickly what we know about meso compounds. Now, there are three main things that I am looking for here, right? So let me zoom in and we will make our little meso chart. Now, if you know what we are looking for here, what defines a meso compound, I want you to pause the video and write them in. Otherwise, a meso compound is notorious for having a plane of symmetry. Meso compounds are also achiral. But our next part is a little tricky. They do have, in quotation marks, chirality centers. Now, those are in quotation marks because we know meso compounds are achiral, but they technically have these sort of chirality centers because they're attached to 4 different molecules. So that is what makes meso compounds a little bit tricky to understand because they still have the R and the S configurations. Now, when we look at these molecules, a few things stand out. If we look at number 1, or the leftmost molecule, right? We notice only one has a chirality center because these 2 molecules are the same. So there is no plane of symmetry, right? No plane of symmetry, so we'll keep that there. And we know that this molecule is not meso. All right, it violates our rule of having a plane of symmetry. Now we look at our second molecule. Now you may be inclined to immediately think that this molecule is not meso because there is no plane of symmetry. But if we rotate along the bond, we do get symmetry. Now, what would a molecule like that look like? Well, we would have the exact same molecule. Forgive my poor drawing skills, or I guess it would be going a little bit down here instead, right? That's why I tutor organic chemistry and not art. All right, so you'd still have it like that and like that. Okay, perfect. And whoa, would you look at that? Plane of symmetry. But what if we had R and S configuration, right? R and S configuration. Well, we'd want one to be R, let's just say leftmost one, I'm totally guessing here. And the right would be S. And now, we know that it could be like that if, well, also another indicator is if we're in both wedges. If they were both dashed as well, they would both be meso compounds. But an example of a non-meso compound, so this one we're going to say meso, right? And an example of non-meso, which, oh my gosh, drawing is so hard. Okay, non-meso here. Let's say I keep this wedge and I make this a dash. This one would be R, and the right one would be R as well. Now I'm completely guessing on the chirality centers here. I believe that they are correct, but I cannot be certain. So if both of these are R, well, that's not a plane of symmetry there, right? This isn't like its mirror image. So it is not meso. It is chiral. Alright, so we want mirror images of each other. So that would mean opposite R and S. Now, our molecule in blue, just for clarity's sake, if our Cl on top was a wedge, and our Cl on bottom would be a dash, well, it would still be chiral. I mean, it would still be meso, because we're bringing this wedge over here and we're rotating it into plane, just like that wedge there. So we're rotating it into plane. So it is still chiral, because see, these are not double bonds. They can rotate. It can rotate freely. So that explains our second compound. Now, the same rules apply to our second compound, right? Right here, right smack dab in the middle, that is a plane of symmetry, right? Now, I don't want to abstract the methyl group, so I'll draw quite lightly over here. That is our plane of symmetry. Now, we can have this one in the R configuration and this one in the S configuration. And that is what makes it a meso compound. But I also wanted to note that we could have both of them being wedge and it would still be meso. Only if one of them is in a wedge and the other is in a dash are they not meso compounds. And so that is an example of the bottom one. Non-mirror images. One is in the wedge and one is in the dash. So that is how you find out which molecules are meso compounds. I hope this video helped.